The unit today is straight line motion, and there really isn't a corresponding section in the book, but it's a good topic anyways to look at. To kind of get some baseline information as the vocabulary down, okay? So in this class, we're going to look at what's called straight line motion. An object or a particle moving on a straight line. So it only exists on that one-dimensional line, moving back and forth. But if you plot the object's movement over time, you could create a curve. So position is one axis, time is another axis, okay? So more often than not, position will be denoted by s of t. So for example, s of t is t squared minus 2t minus 3. Shows position on the number line for those values, and then kind of make some inferences into what the particle is doing, where it's going. You can kind of analyze its motion. At 0, go ahead, plug in 0 for t, you get negative 3. So going to negative 3, right here we're at t equals 0. Plug in 1 for t, and you find that it goes to negative 4. So 1 minus 2 minus 3. Plug in 2 for t, and you're back at negative 3. Plug in 3 for t, so 3 squared minus 2 times 3 minus 3, and you're now all the way over at 0. Plug in 4, and you get 5. So we see a little bit of movement for this object. From 0 to 1, goes to the left. 1 to 2, goes back to the right. 2 to 3, it's still going right, but you see it's traveling further distance. So traveling further distance in the same amount of time, you can say the object has sped up. Then from 3 to 4, going even further distance, it's sped up even more. So you can see kind of if you wanted to graph it, almost a parabolic shape. There's a turning point. We're going left and then right again. So when you talk about an object's velocity, okay, if our velocity is if our velocity is positive or negative or 0, you kind of talk about it unique to the line you're on. So horizontal line, positive velocity, you're moving right. In the vertical line, you're moving up. If your velocity is negative, an object is moving left on the horizontal line, down on the vertical. And of course, if your velocity is 0, then your object is stopped. You're not moving. You don't have any velocity. Now it's important to realize speed is not synonymous with velocity. Velocity can be negative. If your point of reference is the ground and you start here and you fall, you have a negative velocity. You're moving towards your point of reference. Speed does not have direction. Your speed is your absolute value of velocity. Okay, so that's one distinction you need to make. Velocity versus speed. Velocity can be negative. Speed is always positive. Acceleration. Bring this down here. So acceleration is your change in velocity, so the rate of change of the rate of change. So we have a of t, that is the derivative of velocity, that is the second derivative of position. We have a of t for acceleration, v of t for velocity, s of t for position. Why it's not p of t, I don't know, but that's what it is. So think about the car you drive. Objects that change velocity, change your rate of change. Those would be the accelerator. So you want to go, you push down the gas, you move forward. That start you moving forward. The more you press, the faster you go. And then your brakes, you want to slow down. So you want to decrease your velocity. Apply the brakes and you'll slow down over time. Hopefully you're paying attention, you slow down over an appropriate amount of time. As before, kind of looking at horizontal versus vertical, when your acceleration is positive, you're accelerating to the right, or you're accelerating upwards, so you're moving faster to the right, faster up. Your acceleration is negative, you're accelerating to the left or downwards, so you're moving faster in the left direction, faster in the down direction. And then if your acceleration is 0, your velocity is not changing. So if you're moving right, you're still moving right at the same rate of change. Left, up, down, whatever, you're just going in that direction. Think about an object in space. It gets velocity in the direction, it stops accelerating, it just goes in that direction until it's acted upon by another force. So it's important to remember, an object's acceleration 0 does not mean the object is stopped. It's just not moving faster or slower in one way. If you want to go at the same speed, you're on the highway or a straight stretch of road, you would use the cruise control, which the first two cars I drove did not have this, so I really like it, okay? For those long drives, set it and you're going. You won't slow down, you won't speed up. It keeps your acceleration close or equal to 0. So this play between velocity and acceleration, they play with each other. They can be the same, they can be opposite. Assume that you're walking to the right, so your velocity is positive. All of a sudden, there's a large wind, blows you to the left. Your acceleration is negative, because you're being pushed to the left. You're walking right, but you're being pushed to the left. That is, overall, going to slow you down. It's going to decrease your velocity. Alright? So the relationship between velocity and acceleration. How are we moving? So the first column, if your acceleration is positive. Second column, your acceleration is negative. Third column, your acceleration is 0. So if you're moving to the right, your velocity is positive, and your acceleration is positive. So you're moving right, you're being pushed to the right. Overall, you are speeding up. Okay, you're walking forward, someone pushes you from behind. Now you're moving forward faster. may be fast enough that you fall down. If you're walking backwards, someone's behind you pushing you forward, you would be slowing down. Because there are opposite forces at work. One force going back, one force going forward. And then if your velocity is 0, but you have a positive acceleration acting upon you, you are speeding up. Imagine you're standing still, but then like a gale force wind comes, pushes on you. It's probably going to move you in some direction, okay? So that means you're overall speeding up. Whether you had no movement, the wind blows you, now you have movement. So take a moment to pause the video, fill out the rest of this box. Let's see how you do. Alright, so now acceleration negative, velocity positive. Those are opposite forces. So you're slowing down. Acceleration negative, velocity negative. Those are the same forces. You're speeding up. And the last case, velocity 0, so you're not moving, but then something comes to push you. You're going to be speeding up also. Now the last column, no acceleration. So your velocity is positive. You're moving right, you're moving up. You're not accelerating at all. You have a constant speed. You're not speeding up or slowing down. Same with negative velocity. You're moving left or moving down. Nothing is acting upon you. So you're constant. There's no push to speed you up or friction to slow you down. If your velocity is 0, your acceleration is 0, you're not moving, nothing's acting upon you, you have no speed overall. So now looking at some particle motion analysis. So a particle is moving along a horizontal line with position s of t. Do an analysis of the particle's direction, acceleration, motion, and position. So first we have s of t. Let's get our velocity and our acceleration. So s prime of t. That would be our velocity. So derivative of s of t, 3t squared minus 18t plus 24, alright? Now, that's our velocity. Our velocity could be positive, negative, or 0. Now, positive is a lot of numbers. It could be, same with negative, but 0 is one number. 0 is unique, that's when velocity starts, then stops. So let's go ahead. Everything has a factor of 3. Let's factor the 3 out. And then set our velocity equal to 0. So factor that quadratic, 3 minus, or say t minus 2 and t minus 4. So the times when our velocity is 0 are 2 and 4. So those are unique points in time where the velocity is 0, where we're not moving. At an instant, we're not moving. Now, some accelerations may be acting upon us. For example, imagine you roll a ball up a hill. So the ball is rolling up the hill, gravity is pulling the ball down, so the ball starts, and then as it goes, the ball slows down, because gravity constantly pulling on the ball, and then the ball moves back down. Well, there is a single instantaneous instant where the ball is rolling up, it stops, rolls back down. That instant where it stops, that is velocity being zero, because the acceleration of gravity always acting upon it. So imagine the acceleration of gravity pulling this ball down. The ball is going up, but the gravity pulling it down. Eventually it pulls down enough where the ball starts going in the direction. The gravity overcomes the ball's velocity, brings it back. That's a single momentary instantaneous instant where the ball is stopped. And then it starts moving down because gravity keeps on constantly pulling it down. So our velocity, there's a point at 2, and there's a point at 4. Now let's look at the acceleration, s double prime t. So take the derivative of s of prime. So let's go back to the first line, take that derivative. So 6t minus 18. Go ahead. There could be, again, positive accelerations, there's a lot of those. Negative accelerations, there's a lot of those. Zero accelerations, those are unique. So let's find those. So set acceleration equal to 0 and t equals 3. So right in the middle. So let's do some basic analysis of this velocity, acceleration, and then figure out the motion. So for velocity between 0 and 2, okay? Let's plug that into our velocity equation. So let's choose an easy number like 1. Plug 1 in. So plug 1 in to this middle equation right here. Maybe not middle, but factor. So plug 1 in. A positive 3 times a negative 1 when you plug 1 in, times a negative 3 when you plug 1 in. So positive times negative times negative. Positive times negative times negative. That would be a positive. So from 0 to 2, the velocity is always positive. Just choosing a test point within the interval. So from 2 to 4, let's plug in 3. So 3 positive times 3 minus 2, that's positive, times 3 minus 4, that's negative. So positive times a positive times a negative. So from 2 to 4, velocity is negative. Now let's go outside the 4. So let's say 5. So 3 times 5 minus 2, that's positive, times 5 minus 4, that's positive. So positive times positive times positive. So after 4, the velocity is always positive. Now let's look at our acceleration. So we only have 1, 0, so choose to the left of 3, choose to the right of 3. So for the left of 3, let's choose 1. So 6 minus 18, that's negative. And then to the right of 3, let's choose 5. So 6 times 5 minus 18, that's going to be positive. So now we're seeing some play between these forces, velocity, and acceleration. So 2 is kind of a boundary. 3 is boundary. And 4 is a boundary. So in this first interval, from 0 to 2, we have positive velocity, negative acceleration. So the object, the motion, is slowing down. Let's assume this is a vertical motion, vertical line motion. The velocity, we're going up, but there's something pulling us down. So we're going up, but we're being pulled down, so we're slowing down. Now from 2 to 3, velocity is negative, and the top line, and the acceleration negative. So the object moving down and is being pulled down. So it's speeding up in the downward direction. Now, from 3 to 4, the acceleration changes. So we're moving down, velocity negative, but now we're being pushed up. So we're slowing down, we're meeting resistance. There's the bell, get to class. So we are slowing down again. And now the object moving, so it's being met with the resistance overcomes the velocity, and now is pushing it up, and the object is moving up. So the object is speeding back up. And position, we won't worry about that for now. So tips to solve a particle motion analysis problem. This is crucial right here. Find the v of t, set the equal to 0. Also here, find a of t, set that equal to 0. That gives you your boundaries, your intervals, in which to do your analysis. Let's look at this first example together. The rest you want to complete on your own. So for our original s of t position, negative 16t squared plus v naught t plus s naught, that is position on Earth. I believe in feet per second. So let's get the velocity, negative 32 t plus v naught, and our acceleration due to gravity, feet per second, or feet squared per second, negative 32. Now projectile is launched vertically upward from ground level. Now ground level, you have an initial position, so s naught, that is 0. You have an initial velocity of 112. So you have v naught is 112. Alright? So find the velocity and the speed at t equals 3 and t equals 5. So we have our velocity equation. Let's zoom out a little to see that. Okay, so s prime of 3. Gonna plug 3 in. So you do that, you get 16 feet per second. Let's find velocity at 5. Plug in 5 to your s prime equation. You get negative 48 feet per second. And then finding your speed, remember, velocity has direction. So at 3, we're still going up. At 5, we're falling back down. Speed does not have direction. Speed is only the magnitude of your movement. So at 3, the speed is 16 feet per second. At 5, the speed is absolute value, so 48 feet per second. Think of it like the speedometer on your car. Okay, only 1 minute. You really can't take it to class. So speedometer on your car, it's only positive. Speed is positive. Now, how high will the projectile rise? How high? That is position. So we're looking at S of t. Okay, sorry about that. Now I'm back. A student knocked on the door, had to get their folder back for this class. I won't name the student who interrupted me, but you know who you are. Shame. Shame. So anyways, going back, I misspoke earlier. How high will the projectile rise? We know eventually we want position. But to solve that, how high the object rises, at the peak, the velocity will be 0. So we want to set a velocity equal to 0. So our velocity is negative 32t plus v naught. V naught is 112. So solve for t, add 32t to both sides. Divide by 32. T is 3.5. So at 3.5 seconds, the object will reach its maximum height. So position at 3.5. Go ahead, plug that in to position. You get 196 feet. Now find the speed of the projectile when it hits the ground. Now when it hits the ground, its height is 0. So your position S of t, set that equal to 0. So 0 equals negative 16t squared plus 112t plus S naught. S naught is 0. So solve for t, you can factor 16t out from both sides. So t equals 0 and 7. So at 0 seconds we're on the ground. At 7 seconds we're on the ground. But at 0 when you started, that's not hitting the ground, that's taken off. So we want the 7. So we want speed, absolute value of velocity. Plug that in, get 112 feet per second. So position, velocity, acceleration, they all relate to each other. You can use one to solve for another using algebraic solving methods. So take a look at the rest of the examples. Check your work with my completed note online.